for problem number 32, we are asked if there are 10,000 diseases or cases of disease, and we're able to reduce that number of cases by 20% every year. How long until we have only 1,000 cases? Okay, so the problem says, hey, look, there's 10,000 diseases out there, and if we're able to reduce that number by 20% every year, how long, or how much time, or how many years, let's put how long, until we have only 100 or 1,000 cases? Well, this is an exponential problem because we're decreasing by the same rate every time, and so we're going to kind of change this just a little bit though. Because we're reducing, normally we would put 1 plus the rate of change, but now because we're decreasing, it's going to be 1 minus the rate of change raised to the t, and that gives us the total amount as a function of time. Alright, so now let's plug some things in there. Well, the initial condition is 10,000 because that's how many cases we start with. The rate is 20%, but 20% as a decimal is 0.2, and that's raised to the t. And then the final amount we're going to have is actually 1,000. So to clean this up a little bit, algebraically what I'm going to do is I'm going to divide both sides by 1,000, and I get 10 times the quantity 0.8 raised to the t is equal to 1. Now we can solve this on our graphing calculator. There's lots of ways to solve this. Truthfully, if we wanted to do this algebraically, we would just hit this with the natural log on both sides, and that will give us the answer. But the book wants us to solve it graphically. So what I'm going to do is I'm going to graph the function 10 times the quantity 0.8 raised to the x, and then I'm going to graph the function y, the second function y sub 2 is equal to 1. And so what I've done here is I have I've taken the left hand side of the equal sign, this thing here, and I've set that as my first function, and then I've taken the right hand side and I've set that as my second function, and then from there we just look for the line where those two graphs will intersect. And we've done this 4 or 5 times, but basically what we find is they intersect when t is approximately 10.319. Okay, and you can verify that too by just plugging that in your calculator. If you take 10 times 0.8 raised to the 10.319, it will equal 1.